Good afternoon from Barcelona and Budapest. I'm Carlos Perez from McNeel Europe, and I want to welcome you to the third of food4Rhino webinars. Today, we are presenting Pangolin. This is a new Grasshopper app that lets you model your whole structural steel definitions, and later you can analyze this in full detail in Consteel software. I want to present to you Bálint Harmat, software engineer, and Dr. József Szalai, CEO of the company of Consteel, and they will make a presentation and live demo. Then at the end of the webinar, there will be enough time for your questions. So please feel free to use the chat. My colleague Carla Sologuren is also there. She will collect your questions and queries, and then we will pass them to Bálint and József. Also, I want to remind you that this webinar is being recorded, so it will be available on our YouTube channel right after it finishes. If you don't have time today to follow it, the 60 minutes, you will be always you will have always the recorded session on our YouTube channel. As said. Okay, Bálint and József, you can start now the session. Many thanks for being here, and I hope you successful webinar.
Thank you. Thank you very much. Thank you, Carlos. Then I start to share my screen, and I will start with a little presentation about our company, what we are doing. The Pangolin functional presentation will be done by Bálint. The main functions will be presented, and then on a case study, which is a parametric hole, we will present the integration with Consteel and Steelspace. So we are working for Consteel Solutions Limited. This is an engineering research and software developer company specialized mainly in structure analysis and design of steel and composite structures. We have more than 20 years of experience in that field. Headquarters is in Budapest, Hungary. Our products is in use in more than 20 countries. Our sales network with 11 distributor partners works quite well. And we have users from academic research, education, and practical design areas. Our main mission behind all research and development topics is the overall reform of the way of structural design. We think it is very important now, and for this, our opinion is that we need a new generation of user community where the governing rules are collaboration and knowledge sharing. So we develop products supporting these missions. Our core values are high-level engineering for practice. So we have unique engineering methods based on our research team. So we have not only programmers, but we have researchers as well. We develop knowledge-based, highly automated design processes. We put emphasis on modern, efficient design workflow, and we would like to make complex academic solutions simple for understandable for practice. And on the other hand, we use modern software solutions. There is a developer team of enthusiastic and very motivated structure engineers. So all the developers have a knowledge in engineering tasks. We have open-mindedness and responsiveness to the latest technologies, no fear of changes, and we have experience in on-premise and cloud-based solutions as well. And our three main products are Consteel. This is a product family. This is an integrated structure analysis and design desktop software product for steel, composite, and reinforced concrete structures. So it's a classical design tool. We developed just recently Pangolin. This is a Grasshopper plugin for parametric modeling in Consteel and Steelspace. And Steelspace is a brand new product, which is a cloud-based open platform for structural model storing, sharing, and distributed engineering services. So we will basically present Pangolin and the integration between Pangolin and Consteel and Pangolin and Steelspace. So now I take it to Bálint, and he can start to show the functions of Pangolin. Bálint.
All right. I'm here, and hopefully you see my screen of a Grasshopper definition. Is that right? You see me?
Yeah.
Cool. So this is just a functional overview of Pangolin. Here we see all the components that Pangolin provides for structural modeling. This first tab is the parameters tab, which is important in Pangolin because every data type we have is not just an object without definition, but a concrete parameter that can be converted, that can be used by default Grasshopper components or other components, and that carries all the information in itself that was used to create it. So we try to make the entire system where you can easily construct complex structural models without having too much trouble keeping track of the indexes in the trees and lists and so on, because that was one of my pain points when I started with parametric modeling. So here you can see basically the geometry components of Pangolin are just converter components because Grasshopper already excels in this area. And as I said, this can still be used by any other Grasshopper component that expects a geometry. And then we have the structural definition. Here you can see a simple beam definition. We can look at it, it works. There is preview generation in Rhino. And I just want to point out that we have very many possible parameters that you can customize on each beam, but all our components are made in such a way that you can provide the absolute minimum input and it has reasonable defaults. So you don't have to provide everything all the time. Like, obviously you don't always want to calculate for both imperfections. So here is a simple beam definition. And now here is a more complex beam definition, where first I define the transversal main beam. And you can already see that we are able to model haunches in Grasshopper, and Consteel can accurately calculate these haunches so created. These are, of course, also parametric, as you can see. And in this case, I used the same section for the haunch as in the beam, but you can, of course, create welded haunches if you so desire. And what's more, when I model the purlins on the beam, of course, because there is everything in this beam parameter, and I can just ask for the local coordinate system of the beam in a plane and directly provide it to the purlins. So you don't have to manually calculate the angles and so on. You can just correctly lay it on the first try on any sloped beam. And while we're at it, as you can see, this is quite a complex section for the purlins. And these cold form sections are one of the specialties of Consteel and also a unique capability of Pangolin. So here, of course, there are simple sections like this hot rolled eye section. But if you want, you can create really complex cold form sections that I made here. It has various parameters as expected, including stiffeners, which can be customized, removed, and they are also parameterized, of course, in every imaginable way. So I can, of course, disable the top flange stiffener, and that's it. And these stiffeners and the whole section will be correctly taken into account by Consteel. So by going back here, another thing we can see here is, of course, Consteel has layers. You can also provide these. It has everything that is needed for it, and including the correct preview generation. Then next, I wish to talk about the eccentricities, because it is another important thing in structural models. And with Pangolin and Consteel, you can define the structural model with the correct eccentricities upfront parametrically, and it will also be correctly calculated. In this case, we can model it with link elements between the purlins and the beams. And again, because there is every information in the beam, including the edge that the beam is on, even though the link expects an edge, I can just pull in the beam and it will figure out what I mean by it, just like the traditional Grasshopper parameters. And of course, you can define specific stiffnesses for the releases, interface position, and so on. Now, coming over, there are some more structural elements like polygons and rigid bodies, but this basically covers the structural objects that will carry the loads. And then when we go over to load definition and loading in Consteel, we have, of course, load groups according to the Eurocode standards. And each load group has its own specific component with the correct input parameters that the standards can provide and can calculate. And then we can create load cases in these load groups. Again, as you can see, there are multiple ways and very many options. And these like can be favorable. This is a property of the load case, which will be used by Consteel if you use Consteel's standards-based automatic load combination generation algorithm. And finally, of course, we can place loads on the structure. Whoops. Oh, I'm sorry. I'm terribly sorry, but this is not going to be good. And we have a configuration component. Oops. Yes, and even our configuration component is smart enough to figure out if you already have placed one down, then you can't place any more down. And here, right now, we can only configure the force preview scale, so they are not too big. But as time goes on, we expect to implement more and more configuration options that regard to the component family itself. Another thing that I wish to express in the load definition components is that, of course, we have nodal loads, we have line loads, and we have, as you can see, the line loads have many parameters because we also have linearly changing line loads. And what's more important, most of our components are also try to be smart, but try to be not too smart instead of you. So if I look at this line load definition here and look at the edge that I provided the line load, that it should act on this edge, then the line load warns me that the edge is too long for the load bearing surface, but because it was what's the word? It could figure out that you only meant this part of the surface. But if I change this to be so long that it intersects both parts, then it won't try to figure out, it just warns you that this won't do. This is not working. So I hope it came across. Sorry, my English is a little rusty. And of course, there are more specific examples of how you can define loads. You can define them by component loads, and you can define them also by vectors, which I show here. And now I wish to show you another thing with Consteel and Pangolin, because Pangolin doesn't just control Consteel, but it can also consume Consteel models. So for example, if I now bring up Consteel and hide Rhino so you see it, and I draw a beam, or let's say you have any kind of pre-existing Consteel model. Oops. then you can consume it by Rhino. Here I made a simple definition that puts loads in a specific configuration on the beam, and you can automate the often repeated tasks of Consteel. So when there is some robotic task that you have to do, maybe you have got an Excel file with 1,000 rows of forces, then you can automate with Grasshopper and Pangolin, placing those loads in an actual already pre-existing Consteel model. All right. And finally, I will now go back to a case study. This case study was prepared by a colleague of ours called Adam Kish. This is a parametric steel hull. If we take a look here, where there are, it's a real Truman's steel hull. There is everything in it: eccentricities, stiffeners, and so on, loading, load cases, load combinations, which I didn't show, but you can of course manually specify a load combination. And we can send this whole shebang over to Consteel without much ado, which I will do now, like so. And if you only wait a few seconds until Consteel digests the new information, we'll be able to see this steel hull in all its glory. As you can see, very nice. Everything came through, loads and so on. And now, of course, this is the objects are linked together. So if I modify something in Rhino and Grasshopper, say, I don't know, maybe I want more trusses, then I can send these changes over to Consteel. And it is important to note that Consteel will react in every way. So for example, right now, if we look at the original truss definition, we can see that Consteel distributed the loads like 2.5 kilonewton per meters. But if I now send it over the modified version, then it will intelligently modify the model and redistribute the loads for you. And of course, you could do it in Grasshopper. So you could parameterize and create directly the line loads, but Consteel provides you a very much easier method where you can define load transfer surfaces. You can just plate loads. You can put just plate loads on these load transfer surfaces, and Consteel will figure out for you which beam carries how much of that load. So as you can see, the purlins got denser, and we have fewer or less load in every single purlin. And of course, it works backwards. But what's more is, of course, now we saw that it works in Consteel. But I wish to point out that Pangolin itself is completely independent of Consteel. So you can download it, you can try it out and use it without any kind of Consteel license or install. And even you can save out files from Pangolin that you can send over to engineers, or better yet, use our new cloud platform, Steelspace, for sharing these models. So if I come over here and go on steelspace.io. So this is a cloud-based structural model sharing and viewing platform. In the future, we hope to provide a platform for common calculation and solution sharing, where developers can use our environment to distribute their calculations, and you can choose your calculation from a wide range of external developers' solutions on the common Steelspace model format. So of course I can log in. There are some public models that you can view and play around and run calculations against. Now Steelspace required a login, but this login is completely free to register. There is no not any kind of gate before it. And now I log in into Grasshopper so I can upload the model directly to Steelspace. Oops. And if everything works nicely and correctly, oh, and it's already detecting that the model is being uploaded from Pangolin. Very nice. And now the model is uploaded here, and I can view it, delete it, or even share it. In this case, I will share it with my colleague, József.
Szalai.
Oh, I'm sorry. I almost forgot a letter. Save and share. And now he's got an invitation for his model. He can run calculations, download it, and if he downloads it, then he can load it back into Pangolin or Consteel and run more specific calculations on it. And with that, I think I will give the word back to József.
Okay. Please stop your sharing with an escape or something.
Oh, all
okay.
Right.
Then I share again my screen.
Very nice, Bálint, and your English is very good. Don't worry for that. We can all understand everything.
All right, thank you. There were just some words that I forget.
Okay, thank you. So we go on now. Bálint shared me this model. This is my Steelspace account here. And here are my models. Here are the shared models. This is the model which was shared just now from Bálint. This is 3 weeks ago shared with me. There are some public models here as well. And now I would like to show you what can we do with this model. So I click on it. Then after initializing engine, the model is loaded. And here we see in this cloud-based platform in our web browser, we can see the configuration, we can see the trusses, the purlins, the loads. We can switch on the viewer. We can see here the different load groups, what was created in Pangolin. So practically a complete model ready for structural analysis can be seen here. Okay, so it is shared with me. Then if I have the right, then I can perform calculations on this model. There are a predefined load combination in Pangolin. And at the moment in Steelspace, there are some structural analysis and design packages to run. And from structure analysis, we can run a simple linear elastic analysis or a second order elastic analysis or a linear elastic buckling analysis. And in structural design, 2 automatic packages we have now in Steelspace, the strength check or an automatic buckling check, which is based on an overall buckling mode of the structure and the general method of the Eurocode. So now I just show you maybe this, what is unique, quite unique. This is a linear elastic buckling analysis. And I start the calculation. And now it sends the model, the server. It's calculating the model. Until that, I can show you how can you see more about Steelspace. Here are some frequently asked questions, and you can see a detailed description of the different calculation packages about the provider, which is now the Consteel Solutions Limited, but we think that we will have more and more external providers providing very valuable calculation results here in Steelspace for the models which are uploaded here from Pangolin. And here is a detailed description of the linear buckling analysis, what is now running. Then if we go back to the model and see again, then maybe the calculation is over now, and now we can see the analysis result, which is the buckling result, what we performed. Here we can see that it is an overall buckling result. Now the weakest elements are the purlins, of course, which are not supported at the moment in this model, and we can see visually very nicely the lateral torsional buckling of this quite complicated shape profile loaded by the load combination which was defined in Pangolin. So this is what we can do now in Steelspace. We can even comment the model, send the comments back to Bálint maybe if I have something to note on this model. So we can view the model itself and run analysis and view the results. And moreover, we can download this model. So now I use this download function. I download it. If I do not have Consteel, I can download the Consteel as well. And at least installing a trying version, we can see the model opening in a trial version of Consteel. But now I have a Consteel in my desktop, and here is the file which was downloaded. I now open it in Consteel. So this file was defined in Pangolin. You saw the live link with the Consteel, and it was uploaded to Steelspace, and now I download it and open it in Consteel. Here is the file. It's the same what was shown in Consteel by Bálint. And now I have opened the same Grasshopper definition for this parametric frame, portal frame. And there is a function here which I can use now, synchronize on the object with currently open Consteel model. So I can now synchronize the Pangolin model and the model in what was downloaded from Steelspace and opened in Consteel. Now it's synchronized. We can see here in Rhino, and we can see here in Consteel as well. And now all the parametric definitions are working in a live link. So I can continue with it. I can change, for example, the truss to haunched beam. It is changing here in Rhino, and I can now go here and send this definition to Consteel. It takes some seconds, and then we will see the model with haunched beams in Consteel, what I changed here in Grasshopper. And also all the parametric definitions can be applied in this live link on this model, what I downloaded from Steelspace. For example, I just now change the transverse beam from IP400 to IP500. Okay, and again, send it to Consteel, and we can see that yeah, it's working. And now it is IP500. We can see that all the eccentricities are perfect, so it's automatically updating. And of course, all the loads, we have the load cases here, what was created in Pangolin, and we can see all the loads, the defined loads and the distributed loads as well in Consteel for roof layers, installations, the wind loads in different zones, and for snow load as well. And now I can go here and run specific analysis, what is maybe not there in Steelspace, but we can visually see that if I run the same analysis, I will get very similar results, because now I changed the truss to beam, but for buckling still the purlins are the weak ones. And as Bálint was mentioned, in Consteel, one of the main features of Consteel is that we can handle in the structure analysis, structure calculations and design the exact positions of the members. We can calculate them. All the eccentricities can be accurately taken into account during the calculation, especially in the buckling analysis. And we have lots of functions in modeling, and all of these functions are implemented in Pangolin in order to have as realistic model as we can. And that allows the engineer to build the Pangolin model onto a centric beam file, which is of course exact in terms of geometry and positions. And that creates a very, very efficient workflow, including beam definitions and the Consteel calculations. And now I show you some more tricks in Consteel. For example, now if we want to calculate just the main frames now, and we just put the purlins on the right position in order to take the effect, the restraining effect of the beam, what it has actually, then we can run a special analysis in which I just create quickly a so-called submodel, including only these primary members, primary model. You can see the beams and the columns. And now if I have this submodel, then I can run the buckling analysis specially for this submodel, choosing for model portion for the buckling analysis. And I can run again the structure. The complete structure is calculated, but now we can see that the buckling modes are considering only the primary structure. So what is running behind is partial eigenvalue analysis, which takes into account only the as loaded members, the primary model, and the purlins are just taken by their in the stiffness matrix by their stiffening effects. We can see that the purlins are there, so the beams are rotating when they have this lateral torsional buckling form. They are just rotating around this point, what was defined in Pangolin exactly. And these purlins are supporting the upper flange of the beams. And if I have this result, I have more, I can check more buckling modes. Of course, we have all the other ones. So the deformation of the structural model, we can seek all the internal forces or bending moments. And then we can go to fully automatic design check, which takes into account the overall buckling mode of the structure, like it was in Steelspace. And then I can run a completely analytic design check, including not only the strength, but the buckling checks as well. For that, I use this automatic option, and then I run the backlink check and strength check. And we can see that for strength, the purlins are here, and for backlink, this for stability, the primary model is evaluated. It is based on, again, a specific analysis, what we have in Consteel called backlink sensitivity analysis, which in each backlink mode shows us the critical members for which the given backlink mode, which is now this, is really critical, and for which members this backlink mode should be taken into account when we calculate the backlink slenderness of these members. And of course, for each mode, we can have different critical members. And this is taken into account in this check automatically, fully automatically, and that can create a very, very efficient calculation process in which it is very important, again, that all the members are their exact position with an exact eccentricity, which can be defined not only in Consteel, but directly in Pangolin as well. Okay, maybe I can show one more thing here, which is also related to efficient and good design work. It is the so-called, there can be a problem when we use the special analysis model one we have at the corners, and then easily we can use the corner frame corner wizard. Oh, yeah, it's checking the hard key what I have. It's not allowing. Okay, go back. So frame corner wizard, I can put this so-called frame corner object to the model, apply it, and we can see that the frame corner objects are covering those areas automatically in the structural model where we have a different behavior. So in this field, in this area, the beam-like behavior is not relevant anymore because this is a connection area. This area is modified automatically in the calculation to transfer all the effects, not only the in-plane effects like the in-plane bending moment and shear forces, but also the out-of-plane effects, out-of-plane bending moment, torsion, and warping accurately in this area, considering the chosen stiffeners or chosen connection types, what can imagine in that corner. And then I can recalculate the structure using this specific corner tool and run again automatic design checks. And we can see that now this area is taken out from the results because this is checked directly, this area, by the connection design usually. And now, of course, the utilization is much lower because it influenced the backlink mode, influenced the transfer of out of plane and in plane loads as well. And of course, the highest bending moment, what we have here in an imaginary node, is now here where we have directly the end of the column. And in Consteel, of course, there are many more specific tools what we can use for design. Maybe one more what is quite unique, and the last one what I show you is the design of code for members. We can see that this zeta section, what we put here on the structure, I opened it. It is automatically evaluated for all the loads. So we have not only in-plane bending moments or normal forces, this is the stress diagram, but we have out of plane loads as well. So this is an out of plane bending moment because the primary axis system is not vertical, but it gets almost vertical load. So it is automatically taken into account in the analysis, and we receive this specific internal forces and moment. Here are the B moments as well, the warping, what can be also very important in these unsymmetric, stiffened, very complex sections. And we can see the exact definitions of the plates. If reduction needed because of distortional or local buckling, it is automatically evaluated based on the complex stresses, and the standard results can be seen here on the complex, on the effective model. We can see here that there is a change in the stiffness up to here, up to that point. And this is because distortional buckling movement of this internal stiffener. It is the same here for the edge stiffener. It is again automatically calculated based on this specific analysis, in which even for the first order analysis, we can see that how these purlins are moving. These are taking not only in-plane bending moment, what is usually considered, but lots of different internal moments and torsion as well, which can be very important. We can use, of course, sheeting to stabilize these elements, and we have many more functions here in Consteel to evaluate your steel or composite structures. So if you are interested in these products, you can visit our website, consteelsoftware.com, where you may find information about our products, Consteel or Steelspace. You may find also information on beam links, on Pangolin, etc. And on our YouTube channel, you can see a lot of functional or webinar videos and a complete list. We have how to use Pangolin, and introductory and getting started videos for the Pangolin functionalities. Okay, so thank you very much for your attention. I hope it was a useful webinar for you, and I hope that you will try Pangolin.
Thank you. Very, very nice presentation. Thanks for preparing it. I hope people enjoy it. We have more than 90 concurrent viewers, and I'm sure there will be many more after the recorded session is available on our YouTube channel. Now it's time for some questions. There were some comments by the viewers, and let's start with Ivan Burtoyov. He says, well, he's asking about the algorithm in Grasshopper named Hall. If it's possible that you share it. I guess he's talking about the definition. If there are some sample definitions you share on your website so that people can play with them.
I think that maybe not this one, but we will of course prepare example scripts, example parametric models in this Grasshopper plugin in Pangolin, and of course we can share it with the interested users.
Okay, thank you. I guess this was your question, because in the beginning when he asked about the algorithm, I was thinking if he was talking about your algorithms. I mean about your kernel. The kernel. In order to calculate.
I don't think that the kernel is distributed.
Yeah, and what else? Well, there is a very nice comment from Adam Machoviak. He says that it looks like a sharing platform between many softwares, and this opens many doors.
Yes, Steelspace is considered as a sharing platform. We continuously developing the joining software model formats. So we prepare connections between many other software. Up to now, it receiving from Consteel and from Pangolin directly, and also it is open for developers as well. We are already seeking for developers in Steelspace project because we think that can make more efficient the way of design. So many supplementary very valuable results existing in different developers. Maybe they just need a modeling environment, a pre and post process environment, model viewer, graphics, and they don't have enough resource to do this, and we can provide it in a cloud-based platform, and that can be maybe a very good help for them to reach their customers.
Nice. And as you said in the beginning, Pangolin is totally free.
Pangolin is completely free, yes.
And you can save your definitions and send them to other engineers if you like.
Yes. Up to now, Steelspace is also completely free. Okay. So that process up to the Steelspace calculation can be done by any users without any necessary payment or subscription.
Nice. One more question by Enric Magyar. He asks how the Pangolin Consteel link works when the model prepared with similar sections for all the frames, but in Consteel you realize you will need different frames due to additional loads.
Well, you can plot, but you can extend the Pangolin definition with the additional loads and send it over to Consteel, and it will see that there are some beams that unchanged, they won't be changed, and it just puts the additional loads on them. So you can modify the Grasshopper definition and it will still keep the link alive.
Nice. It updates when you click on that button, right?
Yes. And of course, this button is, right now it's a button, but you can pull in a Grasshopper toggle in there, toggle it through, and then for every modification, it automatically sends over the model.
This has advantages and disadvantages because sometimes you don't want it to compute all the time, right? Because of the computer resources. And sometimes you want to wait a little and then click OK now.
Yes, and of course,
it's possible to do it.
Yes.
Real live.
Yes.
Okay. One more question by Steel UPC. He says, have you plugged into Pangolin other functionalities such as Galapagos or Octopus?
Well, right now, there is not much use of Galapagos in Pangolin because in the current phase of Pangolin, which is the first half of what we have planned, we do not get back the results from Consteel, so you can't evaluate them with Galapagos. But it is the theme of our next phase of Pangolin, which is under development in this half year. And when that is released, then Pangolin can get back the results from Consteel, including all these complex buckling results and the Eurocode conform design results. And then you can make a definition with Galapagos on it and do an iterative optimization. So that is the end goal, but we are some months away from that.
Yes, it is important to mention that this is just the first version of Pangolin, which mainly consider the geometry. It is not fully complete, So some structural members are not defined in Pangolin, but we want to continuously develop because we see very big opportunities in connecting to Grasshopper, and the engineers are also seeing that parametric modelization, how efficient can be in their work. So we want to connect very efficiently to this workflow as we try to show it.
Nice. So Henrik Magyar continues with his questions and says, does it mean that for geometrical adjustments of the frame geometry, you need to go back to Pangolin?
Yes. So if you change the geometry in Consteel and then don't change it in Pangolin and send over the model, then of course it will send the original model and
it breaks,
it back.
Right?
It doesn't break, it just modify back your changes.
But yeah. Okay.
You can of course modify in Consteel anything. So you can continue in Consteel, but of course.
But then it will be independent model.
Yeah.
It will break from the Grasshopper model. That's what I wanted to say, right?
Yes.
I hope this answers Enric's questions. Yes, one more question by Alberto Centeno Polo. Are there any elements in Consteel that can now be modeled in Pangolin? Rigid connections between elements, load point insertion, or anything else, for example?
You mean elements in Consteel that can't be loaded in Pangolin?
Any elements in Consteel that cannot be modeled in Pangolin. Yes, so
Yes.
something that exists in Consteel but not in Pangolin.
Yes, there are currently some elements. One of these elements is a trapezoidal sheet object, which models the effect of trapezoidal sheets in purlins. This is right now not in Pangolin, but hopefully will be in some time. And the another big difference is that Consteel has a full suite of earthquake analysis. This is also not parameterizable from Pangolin right now.
Yeah,
These are the main ones, I would say.
And Consteel, there are other objects as well than steel. So there are composite members, composite beams, composite columns with full analysis and design, reinforced concrete, reinforcement objects. Up to now, these are not defined in Pangolin. But as I mentioned, we are working on a complete integration in which practically all the objects, all the members, loads, or whatever effects what can be defined in Consteel can be also defined parametrically in Pangolin.
Yeah.
Thanks for the explanation. So it's in constant evolution, constant development. I hope you will update frequently your food4Rhino app page with the newest releases. And yeah, there are no more questions right now. Many people are thanking you again for your presentation. And from our side also, many thanks again. It was a pleasure. And for the audience, hope to see you again next week or in 15 days. We release new webinars every week, more or less, but sometimes it will be every 2 weeks. But we are working on some exciting new webinars. Many thanks again for your attention. Have a nice day and see you soon.
Thank you very much.
Hello.
Bye-bye.